Hello, welcome everyone. Today we are going to be working on the Test 2 review for Advanced Algebra 2. So question 1 asks you to describe the transformations and then graph the function. First of all, I want to see that there's an x squared here, so that indicates that the parent function y equals x squared. So here is the graph of the parent function y equals x squared. And then from there, we're going to do the transformations. Make sure that you follow the order of operations. So we would start in the parentheses first and perform this transformation first. So that would mean each point would be moving to the left 2 units. So each point shifts left. This point goes left 2. This point goes left 2. This point goes left 2. Everything's going left 2. And then the minus 4 is a shift down 4 units. So I'm going to take this entire parabola, I'm going to shift it left 2, and then down 4. So when you do that to the vertex, left 2, down 4, we end up right here at negative 2, negative 4, and then we'll move the other points along with it. And there is our transformed graph. Make sure you erase the parent function or label that that is the parent function. But I need to make sure that I need you to indicate that this is the graph of f of x, the one that we are asked to graph. Number 2 also has you graph. So we'll start off with the parent function. And so we notice that the parent function is y equals x squared. And when you perform order of operations, you always start in order of operations. So order of operations say that we start with the minus 3 inside the parentheses. So inside the parentheses, if we are subtracting 3, that is an indication that I'm going to shift all my points to the right 3 units. So the vertex goes to the right 3 units. The point at 1, 1 goes to the right 3 units. The point at negative 1, 1 goes to the right 3, and then the other points go to the right 3 units as well. So now this is not the final graph, but this is the parent function shifted to the right 3, which is the equation y equals x minus 3 squared. So now we're going to take care of the 2 in front. The 2, I'm doing 2 next because 2 is being multiplied by the parentheses, so I would multiply with order of operations before I subtract. What the 2 does is it multiplies the y values by 2. So if I look at all of these points, this one has a point of 1, 1. This coordinate pair is 3, 0. This coordinate pair is, that's not 1, 1, that is 4, 1, and 5, 4. What's going to happen to all of the y values? X values will stay the same, but the y values will now be multiplied by 2. So now if I take 0 and multiply it by 2, I get 0. There's a point at 3, 0. 4, 1, if you multiply 1 by 2, you end up at 2. Same thing here. So now the point that was at 4, 1, the transformed point, is now at 4, 2. And the point that was at 5, 4, I'm going to multiply that 4 by 2 and get 8. So I'll take away the red graph. And now the rest of the graph would go off the page. So I'm just going to graph these 3 points. And this is now the graph of y equals 2 times x minus 3, quantity squared. So now it's time to take care of the minus 1. So subtracting would be the last thing I would do in order of operations. So that means all of our points are going to shift down 1 unit. So move the vertex down, move this point down, move that point down. I'll erase my previous graph. Got all kinds of things open in here. Erase my previous graph. here is the final graph of what we're being asked for. So this is the graph of y equals 2, x minus 3 squared minus 1. So that's the graph that we want. Next, we have to identify the vertex. So I look at my graph. I see that the vertex is at 3, negative 1. So vertex is 3, negative 1. You can also look at the equation and say, oh, the opposite of this is positive 3 and then negative 1. The domain, how far to the left and the right does your graph go? It goes from negative infinity to positive infinity. The axis of symmetry is the line that goes straight up and down the vertex. And since it's a vertical line, we write an equation x equals 3. So make sure to write down x equals, not just 3. The range is the lowest y value to the highest y value. So our lowest y value that the parabola touches is negative 1. We include it, and it goes on forever. We could also write that y is greater than or equal to negative 1. Those are equivalent. And then this graph has a minimum because it has a lowest point, and it is at the coordinate 3, negative 1. For number 3, we have to write an equation of the parabola written in vertex form. Vertex form is y equals a, x minus h squared plus k. And so if we're going to write it in vertex form, we need to have a number substituted in for a, for h, and for k. Well, the problem already told us the vertex. The vertex is h, comma, k. And then if we substitute in h and k, we have y equals a, x minus 2 squared plus k, which is 4. So now I'm almost finished because I substituted a number in for h, I substituted a number in for k, but I still need to find out what a is. This other point is going to help us figure out what the a coefficient is. Substitute 1 in for x, 2 in for y. So we have 2 equals a times 1 minus 2 squared plus 4. And now we have an equation that we can solve. So if I follow order of operations, 2 equals a times negative 1 squared plus 4. Simplify a little further. Negative 1 squared is 1, so we have a plus 4 equals 2. Subtract 4 on both sides, we get negative 2 for a. So now we are going to take the fact that a equals 2, or a equals negative 2, and the vertex is 2, 4. Those two pieces of information I'm going to substitute into my vertex formula and write my final answer. Y equals negative 2, x minus 2, quantity squared, plus 4. Now here's a reminder, that overview that you have is a great resource for you to go back and see some reminders of what we did in class. This is a great place. It's where we stored all of our formulas that we did while we were going through all the topics. So now let's look at question 4. Question 4 says define the vertex and then graph the quadratic function. So I look at this and I notice that it is in standard form. Which is y equals ax squared plus bx plus c. And so when an equation is in standard form, we can see the y-intercept. It's that c number. So I know there's a y-intercept at 0, negative 3. I also need to find the vertex. So when the equation is in standard form, you can find the vertex, which is in the form h comma k. We can find the vertex with the formula h equals the opposite of b divided by 2a. This is a formula you want to have memorized for the test. So h equals the opposite of b would be positive 4 over 2, and a is negative 1. And I get a from that coefficient. So A would be -1, B's -4, and C's -3. So H, if I take 4 and you divide it by -2, H is -2. So I know that the vertex is -2, and then I have to find that K part of the vertex. To find the K part, you take what you got and you replace it for X into the original formula. So in that way that I write that is I need to find f of -2. So -2 squared minus 4 times -2 minus 3. If I simplify that, make sure you follow the order of operations. So -4, because -2 squared is 4. -4 times -2 is +8 minus 3. -4 plus 8 is 4 minus 3, and 4 minus 3 is 1. So my vertex is -2, +1. And if that's the vertex, here's the y-intercept. I can reflect that y-intercept across the axis of symmetry that cuts through the vertex. If you reflect it, now you can draw the rest of your parabola. For number 5, we have a projectile that's fired straight up. So this is a word problem. And so you want to make sure that you have a good understanding of what's happening. There's a projectile that's fired straight up from the ground. Its height in feet after t seconds, these are 2 variables, is given by that function. And I look at this function, I see that it's got a t squared, and that tells me it's quadratic, which means it's some type of parabola. I also notice that there's a negative coefficient. So if I try to sketch this, then I know that it's going to be a parabola. It's going to open down. The y-intercept, because it's +0, would be 0, 0. So I'm just going to do a rough sketch. I'm guessing it kind of looks like that, maybe. Then I can start to label what everything stands for. T would be my x on the horizontal axis, so that's time. And height is on the y-axis. And I know that height's on the y-axis because normally right here in that position we have a y, and normally where there's that squared, it's an x squared. So let's see what they're asking. They're wanting the maximum height. So it looks like the maximum height is going to be in the same spot that the vertex is. So I'm going to find the vertex. Since this is in standard form, I'm going to use h equals the opposite of b divided by 2 times a. So -128 divided by 2 times -16. That would be -128 divided by -32. And let's see, -128 divided by -32 is 4. So h equals 4, and that's the h as in the hk, not height. So I know that the vertex is at 4, comma, some number. Well, 4 is the time, so that's seconds, 4 seconds. To find the height, that's the k part of the vertex, I'm going to substitute 4 into each part, each. So -16 times 4 squared plus 128 times 4. So if I type all of that in, we end up getting -256 plus 512. And then when you add those two together, you get 256. And 256 is a height, so that would be feet. So the vertex is 4, 256, but the question says find the maximum height. So they are asking for the height, not the time. So my answer that I'm going to circle is 256 feet. Number 6 asks us to factor. So when I factor this expression, I notice there are no greatest common factors. So I'll set up two sets of parentheses. The first two numbers have to multiply to be x squared. I can do x times x. And then the last two have to multiply to be 45. So I could do like 1 times 45, 3 times 15, 5 times 9. So I'm going to try, I'm looking at 5 and 9. Let's try 5 and 9. I'll know that this works if this product, which is 5x, and this product, which is 9x, if I can add or subtract those two products to be a negative 4x. That will happen if the 9 is negative and the 5 is positive, so it would be x minus 9 plus 5. So my factoring, x minus x 5 times x minus 9. To solve the equation, notice 6 said factor, but 7 says solve. Solve is figure out what x is. So I need to go a little bit further. When I solve, I have a few options. I'm going to solve this one by, I'm going to try to solve it by factoring. So I could factor, I could do quadratic formula, I could do complete the square. I am going to try factoring first. So if I factor it, you have to set it equal to 0. So x squared minus x, subtract 2 on both sides, we get equals 0. Now I'm going to try to factor, bring down your equal 0. To get x squared, I can do x times x. And then to get 2, I could do a 2 and a 1. And right now my products are 1x and 2x. And I know negative 2x plus x give me negative 1. So I will have a minus 2 plus 1. Now it's not solved, it's only factored. To solve it, I need to set each factor equal to 0. And so we're going to get two solutions, x equals negative 1 and x equals positive 2. Number 8 is a word problem. So we want to read it and make sure we understand it. Sometimes word problems have extra information that we don't need. So what I like to do is I like to read the last sentence first before I read the other ones, because usually the last sentence is the sentence that tells you what to do. So number 8, how long will it take for the object to be 8 feet above the valley floor? So how long is asking me what's the time. For the object to be 8 feet, so 8 feet looks like that's the height. So they're asking me what is t when my height, I'm trying to erase here, when height equals 8. So that's the question I'm going to answer. So let's read the problem. An observation deck extends 202 feet out above a valley. The deck sits 152 feet above the valley floor. If an object is dropped from an observation deck, its height in feet is modeled after t seconds, and it's given by that. So if I look at the height, it is a quadratic equation. Y-intercept is 152. So it's going to do something like this. Actually, no, it will not do something like that because that's the y-intercept, but it's also a parabola that's shifted up, like that. So you're standing on this deck, and you drop the object and it falls down. Okay, so this is time, this is height, and it says, how long will it take for the object to be 8 feet? So here, let's pretend this is 8. I want to know what's this time. So what I'm going to do is I'm going to take height and I'm going to replace it into my formula. I'm going to put 8 in for height. So 8 equals negative 16t squared plus 152, and I'm going to solve this equation. I notice that this equation only has t squared and not, it doesn't have t squared and a t. So what I'm going to do is I'm just going to get the t by itself. So you can subtract 152 on both sides. Let's see, 8 minus 152 is negative 144. Is negative 16t t squared. I'm going to divide that number by negative 16, and we get 9 equals t squared. Then I need to take the square root of both sides. Whenever you take a square root of a problem, you need to include plus or minus for t squared, for t. So we see t is positive 3 and negative 3. So I know that t equals time, and I'm answering a word problem. Right now I have positive 3 seconds and negative 3 seconds. Since we cannot go backwards in time, there's only one answer to the real world problem, which is 3. Number 9 asks you to write an equation for a parabola, and it gives you x-intercepts this time. When it gives you x-intercepts, you want to use the factored form. So factored form is y equals a, x minus p times x minus q, where p and q are your x-intercepts. So p and q are negative 1 and 2. I will be finished with this equation whenever I know p, q, and also a. So I'm going to start off by substituting in p, so x plus 1, and x minus 2, but I still have an a that I need to solve for. So to do that, we're going to substitute the other information in. 1 is x, negative 6 is y, so we will say negative 6 equals a times 1 plus 1 times 1 minus 2. Follow the order of operations. We get a times 2 times negative 1, which simplifies to negative 2 times a. Divide both sides by negative 2, and we get 3 for a. So I'm going to take this information, I'm going to put it together and substitute into my factored form. So I know y equals a, which is 3 times x plus 1 times x minus 2. For number 10, subtract, I just need to combine like terms, and you combine them with the sign in the middle. So 8 minus 9 is negative 1. And then 3i minus negative 4i is the same as 3 plus 4, so plus 7i. To multiply, I need to either distribute, or I can use the box method. I've got a box set up. Let's go ahead and multiply. 9 times 9 is 81. Negative 3 times 9 is minus 27i. 9 times positive 3 is plus 27i. And negative 3i times positive 3i is 9i squared. So if I look in my box, I notice that negative 27i and 27i, those cancel out each other. They add each other out. For 9i squared, I squared is the same or equivalent to negative 1. So that expression is the same as 9 times negative 1. And I should really have positive 3i times negative 3i is negative 9i squared. So it's negative 9 times negative 1, which equals, it's a negative there. Draw that better. Negative 9 times negative 1, which is positive 9. So really this entire expression, is, I need a highlighter, 81 plus 9, which is 90. For number 12, I'm going to factor. So when I go to factor, first of all, I'm going to look for its common factor. I noticed I can divide both of those coefficients by 3. So if you factor out a 3, 3x squared divided by 3 is x squared. 12 divided by 3 is plus 4. And then I notice x squared plus 4 is a sum of squares. And the way that you factor a sum of squares is you can divide it into parentheses, take the square root of a squared to be a, square root of a squared to be a, and then take the b squared, but we need an I. And then I'll multiply it out and show you what I mean. So we have 3. If I take the square root, notice there's a plus and a minus. So I have a plus and a minus for this factoring pattern. The square root of x squared is x. Oops. And x. Square root of 4 is 2. But you need an I as well in order to completely factor this. And here's why. If I multiply x plus 2i and x minus 2i, I'll get x squared plus 2ix minus 2ix minus 4i squared. These two cancel out. Negative 4, I squared is negative 1. Negative 4 times negative 1 is positive 4, so this ends up being x squared plus 4, which is what we were trying to factor. So here is your final factorization. This is a check step. Checking my work. For number 13, to simplify this quotient or divide, we need to multiply by the complex conjugate. The complex conjugate takes this symbol of the denominator and changes the opposite, so I'm going to multiply the top and the bottom by 2 minus 3i. 2 minus 3i. Then you multiply straight across. So for the numerator, 5 times 2 is 10. 5 times negative 3i is negative 15i. For the denominator, you can do box method. So let's try box method. Or you can distribute. It's up to you. 2 plus 3i. 2 minus 3i, we get 4 plus 6i minus 6i, which cancel each other out, minus 9i squared, but that's the same as negative 9 times negative 1, which is positive 9. So from this box, we end up with 4 plus 9, which is 13. So that means my denominator is 13. That's as simple as it gets. Number 14 says solve using the square root property. Square root property is just where you isolate the x squared and then take the square root. So to do that, you can subtract 243 on both sides. So we have 3x squared equals negative 243. You can divide both sides by 3. So negative 243 divided by 3 is negative 81. Then when I take the square root of both sides, I see that I have a negative under the radical. I'm taking the square root to solve an equation, but I need to deal with that radical. The square root of negative 81 is the same as the square root of negative 1 times 81. And we have that definition of the imaginary number. It's the square root of negative 1. So x is equal to positive or negative. The square root of negative 1 is I. The square root of 81 is 9. And so I9 looks a little bit different from what we usually write, the way we usually write it, so it should be plus or minus 9i. Number 15 says solve the equation by completing the square. These are the steps for completing the square. You can find them written in your notes or in your overview. So first, this is completing the square. Steps. So the first thing I need to do is I need to make sure that it's equal to the constant, which means I need to subtract 12 on both sides. X squared plus 6x is equal to negative 12. Then I'm going to make sure my a coefficient equals 1, and it does. Check. Then I'm going to add b divided by 2 squared to both sides. So if I look at this, I know that my b is 6. So I'll take b divided by 2 and square it, which is 6 divided by 2 squared. That would be 3 squared, which is 9. So I'm going to add 9 to both sides. X squared plus 6x plus 9 equals negative 12 plus 9. I can factor the left side to be x plus 3 times x plus 3. The right side, negative 12 plus 9 is negative 3. X plus 3 times x plus 3 is the same as x plus 3 quantity squared. Then to solve, I can solve with square roots, which means take the square root of both sides. I'm going to come over here. The square root of x plus 3 squared is just x plus 3. And then the square root of negative 3, the only thing I can think to do, plus or minus, negative 1 times 3. There aren't any perfect squares that are factors of 3, so it doesn't simplify. So x plus 3 is equal to plus or minus I square root of 3. Then you can subtract 3 on both sides. And here's our final answer. (16) says to solve the equation with the quadratic formula. To solve with the quadratic formula, first I need to have it set equal to 0. So x squared minus 5x plus 15 equals 0. Got to have the x squared, the x, and then the 15. I need to identify a, b, and c. A is the coefficient of x squared, which is 1. B is the coefficient of negative x, which is negative 5. And c is that constant, 15. So here's my quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to substitute in all my variables. Then I'm going to simplify following order of operations. So that would be 25 minus 4 times 15 is 60 all over 2. Let's see, 25 minus 60 is negative 35. The square root of negative 35 over 2. And I see that there's a negative in the radical, so all that I can do to simplify that is bring an I to the front and leave it over 2. Number 17 says I can solve with any appropriate method, so I can factor, I can complete the square, or I can do quadratic formula, whichever I want. I look at these numbers, my first choice is always to factor, so let's try. I notice that there's a greater than factor of 2, so I'm going to factor out of 2. And then I'm going to see if this trinomial will factor any further. Two numbers that multiply to be 6 are 3 times 2. Let's see, that would be 3x and 2x make 5x, so that factors. And then to solve, you set each factor equal to 0. Now 2 is never going to be equal to 0, so I have to worry about that one. But then you'll set x plus 3 equal to 0, x plus 2 equal to 0, and solve. So I get two solutions here, negative 3 and negative 2. To do number 18, I'm going to need to know what has to happen to have a real solution. So here's the reminder about the discriminant. The discriminant's the part under the radical of the quadratic formula. So there's the discriminant. The formula for that is b squared minus 4 times a times c. And if I want to have one real solution, then my discriminant needs to follow this. B squared minus 4 needs to equal 0. So I will set this equal to 0. Then I look at my expression. I notice A is 4, B is equal to K, and C is 25. So I'll substitute in everything I know. K squared minus 4 times 25 equals 0. You can simplify that, so that's K squared minus, let's see, 4 times 25 is 400. And then since there's only a K squared, I'm going to get the K squared by itself. I will isolate it. You can take the square root of both sides. Square root of 400 is 20, but don't forget that anytime you take the square root of a number within an equation, you need plus or minus. So k could either be 20 or negative 20. 19 says solve the system with substitution. So I see that both are set equal to y, which means I'm going to replace the y in the second equation with that right there. So when I substitute that expression, here's what I have, and I notice, oh my goodness, it's a quadratic equation. Since it's quadratic, that means I can solve by completing the square, quadratic formula, or factoring. As always, I will try to factor first, so I'm going to set it equal to 0. So 4x squared, if you subtract the x on both sides, we have minus 32x. Add 64 to the like terms. Sorry, add 65 to the like terms. We have plus 64. Then when I go to solve this, I know that I see that there's a common factor of 4. So if you factor out of 4, 32 divided by 4, whoa, hold on. 32 divided by 4 is 8, so x squared minus 8x. 64 divided by 4 is 16. Factor it a little bit further. I can do x times x to be x squared, minus 4, minus 4. And now if I go to set the factors equal to 0, remember 4 is never going to be equal to 0, so I don't have to worry about that. But here, x minus 4 equals 0, so I get x equals 4. And then here I would get the same thing. So there's really just one solution. But when I'm doing a system, notice that the system has both x's and y, so I need to find the y coordinate. Right now I know that my x coordinate is 4. The y coordinate I can get from plugging 4 back into an equation for y. So if I look at the second one and I see this equation for y, I'm going to use that and say the y is equal to 4 minus 65, and 4 minus 65 is negative 61. So I have one solution at 4, negative 61. The last question, there is a typo on your printed copy, so make sure you make this change. It did say y equals, but change it to y is greater than or equal to. And I need to graph the system and then shade the solution. Now you are going to have to graph this by hand, so be ready. Let's start with y is, I'm going to graph the equation y is equal to x squared minus 3, which is the parent function shifted down 3 units. So I'm going to take what I know about the parent function, and I'm going to move every point down 3 units. And here is a quick sketch, 2, 3, 4. There we go. And it's greater than or equal to, so I'm going to use a solid line. So I'm not making the line that I'm drawing right now, I'm not making it dotted. Solid. And then I have to decide which side I'm going to shade. It says greater than, so if you look at the y-axis, the numbers inside the parabola have y values that are greater than the ones outside. So we shade the ones inside the parabola for that part. Then I need to graph y is less than 5, which means I'm going to graph the boundary line y equals 5 with a dotted line. Y equals 5 is a constant function at 5, so I'm just going to draw a dotted line all the way across where y equals 5. And because it says less than, I'm going to shade where the y values are less than 5, so it's all of this. My solution is where the two regions overlap. So this part right here, that's shaded in dark, that is the solution. So that is our review.